Easy, Jermaine, easy. Good night, guys. Well gone.
Evening, sir.
Always stay. Good tonight.
Kinda.
Also leave, kind of. What do you mean by kind of?
Sir, I have only for work I do. Only for work.
Okay. All right. Never mind. You will be fine.
Yeah, man.
So somehow me just feel excited today, and don't tell me that because it's the last leg for this season where I'm excited, but I'm just excited. Honestly. On the then forget rid of.
Sir, me feel good because I get some break so we can actually do some schoolwork, catch up for me fourth time. So.
And that makes sense. Yeah, that makes sense. So instead of me presenting more information to you, you can just go on work upon the one that when we go through already done.
Right, this is sir, right?
Yeah, man. All right. So you'd recognize that I hold on. I make tea, my kettle ready. Hold on. All right. So yeah, so tonight is going to be. Oh, so what I was saying to you is that you recognize that I wrote some whole heap of questions for you. I think there were like 11 of them in total, and sat down and did the solutions, and I'm really hoping that you guys got an opportunity to go through some of those questions. Now I think question number 3, if I'm not mistaken, and don't hold me to that, is a question that Kells asked that question, and I did something like that because I wanted her to see what was happening So I am bringing up the document. Can you open up yours for me, please? I'm bringing up my document so that I can go through that one in particular. Because ask the question, and I want to be able to honor her request. Save. Oh goodness.
So which questions you say you gave us? Because the last document that I have don't see any questions, just the ones that you worked out.
Yeah, man, those are the ones I'm talking about. So I give the questions and then I work them out, Charles.
Oh, okay, so
Yeah, but I think question number 3, where they asked to find the X-intercept. Kelvita asked a question. Was it Kelvita? I think it was Kels who asked a question in that regard, and I said, you know what? Let me just fix up one looking like that so she can see what it look like. So just look at it for me, please. I'm bringing up my where it is application. Yes, it's not application, it's application. I'm bringing up mine as we speak. Oh, that's a problem. I'm using 2 devices so that I can't share from this one if I don't sign into this device. How smart are you? I'm using 2 devices. So, I'm trying to find 2x cubed, 2x, no. Oh, okay. I know where that question comes from. All right. Okay, yes. Question number 3. X cubed minus 3x minus 2. I want to go through that question with you in its entirety, because the last part of that question will segue me into the last area in this or unit 5. Last area in this or unit 5. And it's the area enclosed between the curves. And let me just check unit 5. Then I have one more unit, unit 6, and then we're finished. All right. And I should tell you, I've started preparing a voiceover on differential equations. I created the PowerPoint for one question already. I need to generate some more questions. And then as soon as I do about, maybe about 3 questions I'll do, no more than 4. And then I'll do the voiceover. And once I do the voiceover, I'll convert it to a video and then send it off to you so that you can, at your own time during your Christmas break, you can look through that so that when we resume, God's willing, in January, and I'm going through, you'll be somewhat familiar with what is happening. All right, so that is that. Share screen. And then Okay. So I want us to look at this. What would be your example 3, my example 4? It says a function h is given by h of x, which is equal to x cubed minus 3x minus 2. And that funny looking thing there means R is a member of the set of reals. What all of that means there, don't worry about it. It's just saying to you that R is a real number. Oh, that means we're not going to get no complex roots in it, don't sir? Absolutely, right? So we're talking about real numbers, all right? And what this means is that I want you to see that the function don't have to be named f of x all the time. Neither does it have to be named y. You see this question? H of x. So I say this because I don't know what CCCJ will send. And I don't want anybody to go in the exam and say, geez, I'm sorry, never doing it with h of x. No, it's just the naming of the function. Just like what I have many of you in the class. And all of you have a different name. But you still belong to me. So it doesn't matter how the function is named, just work with the function. All right. Then it says, find the value of x for which h of x is equal to 0. Oh dear. And I say recall pre-calculus, but recognizing that a few of you, well, none of you would do pre-calculus. And I keep forgetting to go back and look at the discrete math, but I doubt this was on the discrete math, but never mind. I will show you. I won't spend much time on it, but I'll show you because the question was asked last time. Then it asks us to find the stationary point, and that's why I put it in blue. That's why I put it in blue. Find the stationary point of h. We know how to do that. It says determine the value or values for which h has a local maximum or a local minimum. Same thing as maximum or minimum. Using the information above, sketch the graph of h of x. We're going to be doing that tonight again. And then now, number 5 segues us into finding the total area enclosed between the curve, right? So I don't know if a couple weeks ago, you remember me taking you around the mulberry bush talking about Kelvita living on one sort of lane, and it started from one end of our house to the other end of, not the house, the yard to the other end of the yard. And I specifically spoke about that example when I was introducing the definite integrals to you. Now, again, I'll go back to that sort of story, right? And it contains the same lesson in order to do this piece. The last piece, question number 5 on this one, it's like about no more than a 10 minutes lesson. You know why? Because based on what it is that I did with you when I introduced definite integrals, I would have included that in it. And it's just for me to show you what it will look like. So it is that you can know how to write a statement. From your write a statement, you're good to go. Everything's a breeze because we have already covered that area. All right. So with any further ado, let us go through the function. And let me just walk you through it. As I said before, I did it in the interest of time. And I know we're wrapping up. And I didn't want not to finish off the applications of differentiation and integration. So I don't have any, because I spent so much time doing the application of differentiation, time was against me in doing anything for applications of the integration. So for that, when we get to that a little later on in class tonight, I'm going to be writing because I have nothing. I need to find some more time to sit and put some more stuff together. All right. So the question says, I know you have it, but I want to walk you through it. The question says, the function h is defined by h of x is equal to x cubed minus 3x minus 2, where x is a member of the set of reals. And then it asks us to find h of x equals to 0. You know, one other way that we can answer to do this, to say it, find the x-intercept. In other words, find the Find the x-intercept. It's pretty much the same thing, right? Find the x-intercept. I know when you find the x-intercept, you put y equals 0, or in this case, h of x equals 0. So to find the x-intercept, you put in y equals 0, all right? Or in this case, y is going to be denoted by h of x. So put in h of x equals to 0. So look at what happens. And Kelvita asked this very question in class last time, and I said to her, I doubt that they will give you something like this with Calculus 1, because I can't recall it being on your discrete math syllabus. But I'm not taking anything for granted. She asked a question, and I don't want somebody lick them head and put a question like that on a paper, and then no, me no Kelvita go say, I'm the answer no. Me ask her until we say it may not come. So let me just go through this one question. So h of x is going to be equal to 0, which is this. So if you look at it, you recognize that I have x cubed. There is no there's no x squared term. So I'm replacing my placeholder. So I'm using 0x squared as my placeholder. All right. So 0x squared is used as a placeholder. And that placeholder is there because I don't have an x squared term in it. I don't have an x squared term in it. All right. So now I said here, recall trial and error. So I'm going to be using trial and error to solve this equation. What the question is asking us to do is to solve the equation. All right. So here, what is going to happen now? So I'm doing a long division. Now the long division is really not difficult. Let me find something and show you semester 1 here. Let me do a crash program with you. Oh my Lord, my system is really going. It takes so long for it to come up. Mercy. All right, so let me do a new share here now. So this one here is talking about a polynomial division. It's talking about a polynomial division, and I'm just going to be just to walk you through something, because when I'm normally teaching the long division, polynomial division, I normally go through this thing. Let me bigify this before Lady B asks me to bigify it. So look at what happens. You remember when we were going to look at school and teacher says divide 5 into 9, and you draw, you look at something like this and say 5 into 9 goes 1 time. What do we do when we get this 1? What do we say?
Times it times 5 times.
You times what?
5
Five
times
times
1 times 1.
Very good. So next time I hear you say 5 times 1 is 5, and I put the 5 here, so don't.
Yes, sir, but you
Yes,
have to
sir.
subtract it too.
And you have to do what?
Subtract it. And that's
Very
it.
good. Very good. Now, excellent. So you have to subtract it. And so what is this 4 known as?
Remainder.
Remainder.
Ah, excellent. Excellent. Right. So that's all. So when we're going to look at school, they never tell me the big picture of it, say, don't forget this, because sometime later on in big school, it's going to come back to haunt us. Well, not really haunt, but again, see it again, right? So technically, that's the same thing. So we say 5 into 9. 5 into 9 goes 1 time. 1 times 5 is 5. You subtract. Every time you draw that line, you're subtracting. Now, when you're subtracting, you're finding a remainder. Then we say 5 into 4. Oh, I can't. But if teacher says to write it in decimal place, you're then going to add a decimal point and then a 0. And then when you say 5 into 40 goes 8 times. So you're going to get 1.8 as your answer, right? But we're not going to go through, we're not going to go into that. Right? So the answer would have been 1.8, but we're not doing that. What we're doing, we're looking at 9 is equivalent to 1 times 5 plus 4. The quotient, the quotient times the divisor plus the remainder is going to equal to the polynomial. So it's what it says here. The 1 is known as a quotient, the 5 is known as the divisor, 9 is known as a dividend, and 4 is known as a remainder. Please note the polynomial is equal to the divisor times the quotient plus the remainder, right? So if you want to get back this 9, we just multiply 1 by 5 and then add it to the remainder and we're good to go, right? That's what we do. And when we're going to little school, trust me, they didn't tell me that, I don't know about your little school, but my little school for sure. They didn't tell me how to go back and double check my answer right here, right? Me to just have to know, so boy, a one shot, I'm gonna better get it right, all right? Now, similarly, if we were to look at the function and we say 2 is divided into 10, we're going to say 2 into 10 goes 5 times, and 5 times 2 is 10. We put the 10 there and we subtract, and we get 0 as a remainder. Now, what does that tell you? If we get 0 as a remainder, what does that tell you? That the divisor is a factor of the polynomial, meaning say, this divisor here, 2, can go exactly into what is under this square root sign.
No remainder.
That's what they taught us. That's what they taught us. They taught us that it has no remainder, but it's actually lied to us. The remainder is actually 0. So I don't want you to say no remainder, and don't feel bad about it, because I used to say that too, until I got to big school and I recognized that they were associating 0 with nothing, and 0 is plenty things. Because if you forget one check, Sash, bonus in a Christmas year with $100,000, I mean, say, show me now, but I write one of the 0, yeah. Me know, say, you're going to carry to the foot of the cross, because that $100,000 going to come down to $10,000.
Yeah, true, sir.
No, we can't play with you. You're crazy. All of $90,000 me I go away with? No, man. You tell me how much Jesus loves me and put me to the scripture in the Bible. So, you know, sometimes some of the things that they say to us when we're going up into liquor school, like carry over the equal sign. No go so. But guess what? I remember go to high school, you know. Remember when we in high school, man, and they have a very, oh Lord, forgive me, but a very sexy teacher. All if we never want to learn maths, we did have to learn maths. And we argue, me in a first form, you know, and she a teacher, you know, and we argued every day for math class. And some days when I decide, say, I'm not going to speak, she says, no, my class can't go on if you think that you don't argue. Come on, let us, because she tell me, say, me I tell her, say, me I carry over the equal sign, and she tell me, say, nah. I said, no. My primary school teacher is the best teacher ever. And you notice anything teacher tell you, you know, when you go to primary school, you know, it's a gospel that mother and father cannot undo what teacher tells you. So we fought many times over. Still love my primary school teacher, but guess what? She told me about, don't worry about negative signs, because you will never ever be able to take a big number from a small number. She lied to me, but I forgive her because I know what she was doing. She didn't want to give me information overload. But I don't say that to students. I say to them, soon come, little later. You're not ready for that one yet, just yet, right? So that in the back of their heads, they don't, you know, they can be prepared that something like this will come up at some point later. So we had quite a bit of conversation, but it was good conversation, you know. It was good falling out, you know, because I mean, I was able to appreciate the mathematics from an early age. So we're not going to say it don't leave a remainder. It does, but the remainder is 0. All right. So now, and then now we can say that 2 is a factor of the polynomial. 2 is a factor of the polynomial. So what is going to happen is going to be 2 times 5 plus the remainder, 0. All right. So that's exactly what that is. And then now I'll be moving into an example. So now that I've given you, hey, Yon, Now that I've given you a little piece of what, oh good Lord, piece of what that is, let me now go back to, okay, let me go back now to your stuff. All right. So we are going to be factorizing it. So it says trial and error, because you notice in the other case, in the two cases I look at, we know what the divisor was. One was 5, and we know what the divisor was in the other one, plus 2. In this case, the man them don't tell you what the divisor is. They did not indicate what the divisor is, so we know how to go find it. So we're using trial and error. We're using trial and error. Now, the syllabus normally tells us that we're not going to pass 3. If we pass 3, it means that it's a non-question for you. So what we'll have to do is to try when x equals 1, it don't work. We try when x equals -1. That don't work. We try x equals 2. That don't work. We'll go up to x equals -2. That don't work. We try x equals 3. That don't work. We go up to x equals -3. And by the time you reach -3, you must get your answer. We don't normally give you anything above -3. Sir, we are talking about. All right, here goes. So I am going to try. I tried x equals 1. But when I put x equals 1 in here, 1 cubed is 1. 1 minus 3 is -2. Minus 2 is not equal to 0. So 1 couldn't work. When I try -1, -1 cubed is -1. -1 times, let me see if I have it in here because I want you to see. Oh, come on. What am I looking at, Lord? Okay. And this is some pre-calculus stuff, so you don't have to worry great. I'm just looking to see if I have anything with to show you exactly what it is that I'm talking about. As I said before, I don't expect them to give you, but I just want to show you as a just in case. And unfortunately, okay. All right. So this is what I'm saying to you now. So in a case like what it is that we're looking at, we're given a polynomial to factorize, and we don't know what the factor is. We don't know what the factor is. We're going to try, and in this particular case, let me show you. In this example, I'm using trial and error. In this example, I'm using trial and error. And I'm going to say let x equals 1 to determine the polynomial. But guess what? I was very strategic in the values that I use. You notice I only started off with -1 and them things there. Hold on a minute for me, please, guys. Sorry about that. Right. So let me just show you why I didn't go with the +1 -1. When I look at the polynomial, I recognize that every term in the polynomial is positive. So if I were to substitute another positive value in there, I won't get 0. So that's why I was very strategic in only using x equals -1, x equals -2, and then x equals -3. If I had negative numbers inside of that, polynomial, I'd go x equals -1, then x equals +1, then x equals -2, then x equals +2, so forth and so on. So when I substitute -1 into the polynomial was equal to 6. It's not equal to 0. So I can say that x plus 1 is not a factor of the polynomial. Then I move on to substituting x equals 2, -2, I'm sorry, and I got -2. So, it's still not a factor of the polynomial. Then when I substitute x equals -3, voila, I get x equals 0. Now watch this. So x is equals to -3. So it implies that x plus 3 is a factor of the polynomial, because what I'm doing is adding 3 to both sides. When I add 3 to both sides, -3 plus 3, I get 0, and then I'm going to have x plus 3. So I can say x plus 3 is a factor of the polynomial, and look what I do. I put my x plus 3 outside here and then divide through the polynomial, and my remainder must be equal to 0. All right? So that's just a pictorial of what it is that we're going to be doing. So in the interest of time, didn't have enough time, so I did not show you
You
this.
can repeat something. You mentioned something like, oh, you know to use the -1. I never hear what you
So what I was saying to you, the polynomial lexicon that they gave us, every term in the polynomial was positive. Every term in the polynomial was positive. So if I substitute a positive number again, I'm not going to get 0. So it's like in this term now I have positive and negative values. I have to substitute the +1 and the -1. If every term in this polynomial x cubed, if I gave you x cubed plus 3x plus 2, it don't make sense to put in any more plus values, because you end up getting a bigger plus. Talk truth.
Yes, sir.
Yeah, man. So what I'm doing now, so it's just you working smart and not hard in an exam. So you don't waste time looking for something when you know that it's not going to work. All right. So let's go. So I would have gone through x equals +1, didn't work, -1 didn't work, +2, and yes, x equals +2. So therefore it worked for me at x equals +2. So therefore x minus 2 is a factor of the polynomial. So I would have found the factor of the polynomial, and that's what we call trial and error, right? So this is my polynomial that they gave us. This piece here is a polynomial that they gave us. And watch this now. This is what I want to show you, all right? And I'm not going to do any more than just this one question, because I really and truly don't expect them to give you in the exam, this exam coming. I really don't expect, because polynomial division is not on your syllabus. I'm spending a little time just to run through it quickly with you so that you have these notes already. You can take some time and look at it and just appreciate it, should in case it comes, but it shouldn't come. I mean, I'm like 99.9% that I'm not going to give you something for you to go and, put x equals, y equals 0 and so, all right? Business calculus, yes, because they would have done it in pre-calculus. But I want to show you nonetheless. Information can't be lost. So watch me here. X, don't blink, x into x cubed goes x squared times. X into x cubed goes x squared times. And then I'm going to say x squared times x is x cubed. But because I have two terms here, I have to use this x squared now to multiply this -2 to give me -2x squared, which is not different from what it is that we did a while ago when we were in middle school. Remember, 5 divided into 9? In order for you to find the remainder, I have to use my quotient up here to multiply my divisor. In order for me to find the remainder, and every time I draw this line, I have to subtract because I'm finding the remainder. So when we had a 5 into 9, 5 into 9 goes one time. In order for us to find the remainder, we had to multiply up here, by down here, and then put it here and subtract it to find the remainder. So what it is that we're doing here is finding the remainder every single time. That's what we're doing. We're finding the remainder every single time. So let's go again. X into x cubed goes x squared times. And then x squared times x is x cubed. And x squared times -2 is -2x squared. I'm subtracting. And that's why I put this minus sign out here and put it in the parentheses, because it's not only this number that I'm subtracting or this term that I'm subtracting, I'm also subtracting this term as well. So now I'm going to say x cubed minus x cubed is equal to 0. So you recognize there's no x cubed term here because I've eliminated it. And oh dear, I thought I had plugged it in. This computer is, oh Lord, hold on. Please don't go, don't go, don't go. All right. And then this is going to be this negative sign multiplied by this negative sign, give me a positive sign. So now I'm going to say 0x squared plus 2x squared gives me a 2x squared. And that's why I get the 2x squared right here. Then I'm hauling this -3 down right here. Sir, but when we were doing the other one before, we never haul anything down. I agree. We didn't, because we had only one divisor. In this case, we have two divisors. So every time you see this line here where we're subtracting to find the remainder, you notice I have two terms, 1, 2. Subtracting 9, 1, 2. Subtracting 9, 1, 2. So any number of terms you have outside here will be the same number of terms that you're going to be subtracting under here. All right? So I have to carry on this -3, which is here. Then again, I'm starting the process one more time. Watch me. How many times can x go into 2x squared? It's going to be 2x times. See here? This 2x times. Then I'm going to say 2x times x gives me 2x squared. And then 2x times -2 gives me -4x. Again, I'm subtracting, but remember, I'm subtracting, but I have two terms. So I have to put them in parentheses to show you that this negative sign is governing not only the 2x squared, but also the 4x, the -4x. So watch happen now. Watch what happens now. 2x squared minus 2x squared is equal to 0. So I have eliminated the 0, the x squared term. So if you recognize now, I've eliminated the x cubed. Now I'm eliminating the x squared term. And then the sum you have to go on until we eliminate until we get to a number. All right? And then now remember, this negative sign multiplied by this negative sign gives me a positive sign. So watch me. -3x plus 4x is going to be a positive x. It's going to be a positive x. And then I'm taking this -2 all the way down here, because remember, at all times, I must have two terms here. Why, sir? Because I have two terms here. Then I say x into this x goes 1 time. And 1 times x is x, and 1 times -2 is -2. Yeah, this -2, not that x. So this is an x, because remember, this was a remainder. And then now I'm multiplying this 1 times this x to give me this x. And then this 1 times this -2 to give me this -2. All right. And then again, I'm subtracting. X minus x is 0. This negative sign, -1 multiplied by this -2 gives me a +2. So -2 plus +2 will give me 0. All right. So this is how we do our division. Now, there's a point that I want to bring across. When we get our quotient, we have to now go ahead and factorize our quotient. So I'm making a statement that this x minus 2, the same thing I showed you a while ago, this times this plus the remainder will give me the original polynomial that we started off with. But here, the quotient, see the quotient here? X squared plus 2x plus 1, x squared plus 2x plus 1, this quotient here. When I factorize the quotient, I'm going to get this. It's a perfect square. So either x is going to be equal to 2 from here, or x is going to be equal to -1 2 times, which is why I call it twice from here. This one going to give me x equals -1. So is this one. That will give me x equals -1. Now, what's the point I'm making? This x equal to, this x equals -1 2 times are going to be used to be placed on the graph. Are going to be used. Every value that you calculate in the stationary point question must be represented on the graph. And let me reiterate the point. This division, I don't expect it on the paper. It is not on the syllabus. you can look at your syllabus and you can say, sir, I found it. I have looked, it's not there. I only included it because Kelvita asked a question. Then, sir, would they ask? And I remember she was following up something up with what Lexington said. Sir, would they ask you to find when y equals 0 to go and solve? And I said, no, but you see, I like to err on the side of caution. And I say, you know what? Just in case money let them head, let me just put it right there. So that's what I'm putting in. So I'm not going to even spend more time on it. I'll show you what we did right there already. Let us go into what I know will come on the paper. What I know will come on the paper. So they want us now to find the stationary point. They want us to find the stationary point. Let's go back up. Oh, but you have the question. I don't have to go back up. Find the stationary point of H. So they want us to find the stationary point. So remember, to find the stationary point, we have to differentiate. We have to differentiate. Look at that differential, H dash of X, and tell me if you agree.
Yes, sir.
Just one?
Yes, sir.
Nice. Now remember, for a stationary point, dy by dx is equal to 0. The same thing for H dash of X. So I'm going to set my differential equals to 0. Um, 3x squared minus 3 is equal to 0. Then I'm going to solve for x. Then I'm going to solve for x. So, why did I do it this way, though, Lord? I don't like, you know. So we're solving for x. So we have 3x squared is minus 3 is equal to 0. Then we're going to have 3x squared is equal to 3. Dividing both sides by 3, I'm going to have x squared is equal to 1. X is going to be equal to plus or minus 1. So those are my critical values. See here? Critical values. X is equal to positive 1. X is equal to negative 1. Those are my critical values. In order to find my critical points, I have to substitute this critical value into the original function. See here, the original function. Oh, come on. The original function is there. Into the original function. So anywhere in the original function, I see x, I'm going to put positive 1. So this is going to be 1 minus 3 is negative 2. Negative 2 minus 2 is going to be negative 4. So h is going to be negative 4. So my critical point is going to be 1 comma negative 4. See here, so 1 comma negative 4. Similarly, I'm going to be doing the x equals negative 1. Anywhere in the function I see x, I'm going to put negative 1. Negative 1 cubed is negative 1. Negative 3 times negative 1 is positive 3. Negative 1 plus 3 is going to be equals to positive 2. And positive 2 minus 2 is going to be equals to 0. So this is how we got the 0 right here. So the other critical point is going to be 0. Now, I expected 2 critical points. Can anybody look at the question? It's on this page. Look at that and tell me why it is that I expected to have gotten 2 critical points. Look at it and tell me. I told you before. So look at it and tell me.
Sir,
Repeat the question, sir.
X square, sir.
Very good. Very good. My question was, how did I know that I was going to get 2 critical points? Remember, it is h dash of x that I was solving. And the highest power in h dash of x is squared. So it tells me that I have 2 values. The highest power in the polynomial tells us how many values we have. when we're solving a polynomial function, the highest value in the polynomial tells us how many values, how many answers we're supposed to be getting. Tells us how many answers we're supposed to be getting. And in this case, it's 2. Thank you. That was Krishna for remembering. No. I'm showing you this the other way. So I'm using both methods. Last class I used the graphical method. Now I'm going to go to the second derivative method. You choose which method you're most comfortable with. I heard you last class, you said that, sir, no, me not say that look like no n. That don't look like no n. So I said, okay, fine. Maybe they don't like this method. But I'm showing you both methods because I want you to be able to select which one you're most comfortable with. All right. So I'm going back to method 1 now. And then of course I'll go to method 2 for the other question, or I don't remember what I did exactly. Okay. Are we good so far? Remember, to do the stationary point, we get the original function, differentiate the function, set the function equals to 0, solve for the critical value or values. When we get the critical value or values, we substitute it into the original function, and the values, the corresponding values that we get from it will give us our critical points, which is exactly what we just did right here. Any question?
No question right now, sir.
Okay, cool. All right, so let's go. So part 3 of the question. In other words, here for part 3, they're asking you to classify the stationary point. They're asking to classify the stationary point. What it is that they're asking right here is just to classify the stationary point. Determine the value or values of x for which h has a local maximum or a local minimum. Not or, but and a local minimum. Because you have 2 points, and it's a cubic graph. You know that one going turn up, one going turn down. So therefore, if you have a local max, local min, we need to say which of them has a local maximum or a local minimum. All right? Let's go. All right. Hold on now. Okay, so let's go. So I'm using the second derivative method in this case. I'm using the second derivative method. So I'm going to differentiate my first derivative once more. So in order to get my h double dash of x, I'm going to differentiate my h dash of x. 2 times 3 is 6, and I reduce this by 1, so it's going to become 6x. And the differential of negative 3 is 0. So look at what happens. I have my differential, my second differential, with h double dash of x going to 6x. I'm classifying my stationary points. My stationary point is negative 1, 4. Sorry, 1, negative 4 and negative 1, 0. So at -1, 4. So I'm telling you which point I'm using, which stationary point I'm using. So when x is equal to -1, sir, we get -1 from, see right here, so this is the x value, and this is my y value. This is my x value, and this is my y value. So when x is equal to -1, I'm putting 6 times, when x is equal to +1, I'm sorry, I'm putting 6 times 1, I'm going to get 6. Is that 6 positive or negative?
Positive.
Positive.
And when it is positive, we have a local minimum. See here, it's positive, it's greater than 0. So we have a local minimum. So remember, when it's positive, it's a minimum. So we have a local minimum there. So let us look at this other one. 6x at x equals, when x is equal to -1, 6 times -1 is going to be -6. That value is less than 0, so we have a local maximum, right? So I can tell you that I'm going to have a maximum at the point -1, 0, and a minimum at the point 1, -4. See here? Over here, so is -1. This point here, where it touches the x-axis, is going to be -1, 0. And I'm saying it's a maximum. Look at the maximum. Remember I said to you that the maximum look like an n for negative. See here? See the n right here, n coming up right here. So when it curves downwards, it means that it's a negative. And incidentally, I use the same graphing tool to do the stuff. So I'm going to get this to be negative. This is going to be negative. All right. And then my local minimum, the minimum is going to be a u, which is positive. So it turns upwards. So it goes this way. It goes this way. All right. Now the question didn't ask you, but I'm going to ask you now. I'm gonna put it in there, and I'm gonna call that determine the point of inflection. I'm gonna give 2 marks. Point of inflection. Remember, to determine the point of inflection, we are going to find the second derivative. And when we find the second derivative, we're going to set it equal to 0. Solve for the value of x, for the value of x. And it is going to be a value of x and not values. Why? Because the point of inflection occurs between turning points. So a point of inflection is going to occur between this point here and this point here. And remember, sir said to you, this is going to form in the midpoint of the stuff. Let me see if I can bigify this somewhat and show you what I'm talking about. What I'm saying to you, my point of inflection is going to be the midpoint between my turning points. Here is one turning point. Watch me. So you're going up, you're going up, you're going up, you reach a particular, the maximum height. So when we speak of maximum height, that's where it is a negative point here because it's turning to go down. And then now you reach a minimum point and then you're going to go up. So this is my sextograph, I call it. My sextograph is very curvulous, and this is what the x cube graph looks like. That's what the x cube graph looks like. All right. So what I'm saying to you, let me say it again. My point of inflection normally goes between my 2 critical points, and it is found somewhere in the halfway region. So to be honest with you, I don't even know. Right here, such a there, so I don't even know if it falls at the 0, -1 or the 0, -2, but it's somewhere off here. So somewhere in the middle right there, so is my point of inflection. So let us calculate it and see what it looks like. Let us calculate it and see what it looks like. Let me reduce this thing somewhat. Let us calculate it and see what it looks like. The point of inflection. Point of inflection. I'm going to be using the second derivative. Copy. Oh dear. Undo, rockstone, bold. Point of inflection is that. So I need to put my question 4 here and change this to 5. And then I paste that there. So I'm going to set my derivative equals to 0. I'm going to set my second derivative equals to 0. So what I'm going to do is put that piece equals to 0. What does that imply? It implies what? That x is equals to?
Six, sir.
X equals to what?
6.
X is equal to -6.
If 6x is equals to 0, what's the value of x?
1/6.
Oh,
6.
0.
What? I would have been 6 divided by 0.
Yeah. No, not 6 divided by 0. 0 divided by 6, Kelvito. Hey, Kels. I'm going to buy a buckler rum, you know. You can't
Sir,
have-
tell me when me can come feet.
You're supposed to be denouncing me. What kind of teacher is telling the student to go and drink some rum? You're encouraging my slackness. Right? So it's you're dividing, you're trying to find the value of x. So you're dividing everything now by both sides by 6. So that you can free up that 6x to just be x. So you're going to have 0/6, which is going to be equal to 0. So you know that your x value is equal to 0. And in order to get, remember it says, we call it now, point of inflection. A point of inflection has an x value and a y value. So if this is the original function, it means then that in order for me to find a point, the other value, I have to substitute it into the original function. There goes the original function. So anywhere in the original function I see x, I'm going to put 0 because that's my x value. Anywhere in the original function I see x, I'm going to put 0. And then now my h of 0 is going to give me -2. So my point of inflection is going to be equals to 0, -2. Are you surprised that we got 0, -2? Anybody surprised?
Sir, at first, x was equal 0.
No, man, I'm saying if you're surprised that 0, -2 is a critical point, is a point of inflection.
No, sir.
You remember when I guesstimated it, it looks like it was sitting right on the y-axis right here. So you remember I said that?
Yes, sir.
Yeah, man. Even without me doing the question, because you can see now that I just did the question a while ago. right? I was able to say that the point is going to fall somewhere there. So it proves a point that I'm trying to make to you, that the point of inflection is really the midpoint between the turning points. Then, sir, what is so special about we call it the point of inflection? You know, you can bend the graph at that point in time. The graph inflects at that point in time. That's what it means. It inflects at that point, at that specific point. So that is going to be, just remember, it's going to be the midpoint between my two turning points. Right here, so, right here, so. Now, when I sketch the graph, let me show you something. It's my point of inflection. This 0, -2 is right here, so. That point is right there. What is also represented on my graph is 1, -4. Watch me. 1, -4 is right here, so that's my minimum value. 1, -4 is right here, that's my minimum value. My maximum value is -1, 0. See here, -1, 0. That's my maximum value. And then there are 3 other points that must come out on the graph. Sir, where do you get the 3 other points from? Okay, thanks for asking. The x equal 2, the x equal -1, and the x equal -1. Remember, this one come twice. So -1, and 2. See it here, so? See it here? See the -1 right here, so? It cuts the graph at -1. And it cuts the graph at 2. So how you know that is 2? If this is 0 and this is 1, that means this is 2, then this is 3, then this is 4, then this is 5. So you know exactly where the graph cuts the x-axis. There are times when I'm plotting the graph, and whenever they don't ask us to calculate the x coordinates, I mean where the graph cuts the x-axis, I never normally pull the graph above the x-axis because I don't know what value it is. I don't pull the graph there, right? But the point is, anywhere they ask you to, anything that asks you to calculate in the question, the critical points or stationary points or turning points, the x-intercept or the y-intercept, the point of inflection to indicate the maximum or minimum, all of those values must be represented on your sketch. All of those values must be represented on your sketch. Are there any questions?
Sir, not a question, but more like a favor, sir. Sir, we don't normally ask for a break, but sir, I think I really need at least 2 minutes break, sir.
Oh, no problem. No problem. No problem, man. Okay. So let us just go now then for it. I will come back at 8:30. I'll give you 10 minutes.
Yes, sir.
We'll come back at 8:32. All right, take a break. Cool.
Yes, sir.
I hope I don't drop asleep. Yeah, man, no problem, hon. If I don't come back at 8:32, call my phone here.
Okay, sir.
Sir, you don't drop asleep.
I try not to.
You finished drinking tea yet, sir?
It get cool, sure.
All right, so you have the time now, sir. You know, one
I
more
want to
minute.
back down. All right, cool. We'll do.
Buzz it in the microwave.
No, sir. I don't use microwave at all. And I don't know why I have one and I don't use it. Them things are not
Sir,
unsafe.
if you're really not going to use it, give it to me. Let me donate it to our home.
All right, no problem. I will have a conversation with the boss lady and let you know.
Sasha, you go school. Boss didn't argue with her microwave. Because she use it though. Yeah.
No, but actually we really don't use it, you know. The truth is, but you know, we'll talk.
Sir, I will remind you, you know.
Yeah, man, sure, remind me. You know what? Come with me, start back here because I don't know what you're talking about. Call it a night. You're watching table tennis. Come, let's go. I gave you. Oh Lord. I give you 20 minutes. All right, let's go. What's here? And tell me a CMSA sound. CMSA sound. Oh goodness. All right, let's go. So where were we? We were at the point of inflection. Okay, and we agreed with that. And then now there's the last part of the question, which is what I want to see, where I want to start. It says find the total area enclosed between the curve and the x-axis and the values x equals -2 and x equals +2. Me soon come, I am right there now. All right. Okay. So let us go. Hold on a minute, please. Let us go. Let us look back at the original function for me, please. The function is copy part 5. Part 6. So that's the function. X cube. I was checking something here. Give me a minute, please. X cube minus 3x alpha x minus 2 positive 2 negative 2 and then all equal negative 1 negative 1 negative 2. And then all right, I'm going to do the calculation 2 ways. Just double check how the one works. I'm going to do the calculation 2 ways. And the first way is what I know you know how to do. Let me go back to the question. The question says, find the total area enclosed between the curve, the x-axis, and the values x equal -2 and x equal +2. The curve, see to yourself, the curve and the x-axis and the point x equals positive 2, and the point x equals negative 2. So watch me again. Watch me again. I know you guys tired. I know you guys are tired. I know you want the class to be finished. Funny story before I continue. Funny story. Before I started off with you, I said, I'm going to finish class at 9 o'clock tonight and give them an hour. But because I give you 20 minutes already, we're going to go back until I went about my 20 minutes, right? But I know you guys are tired, but we still have something to do. So I'll just ask you to just, don't blink. Just keep the eyes open, please. I beg of you. Let's go. So the question says, to find the area enclosed for the curve is in blue, the x-axis, and the point x equals positive 2 and negative 2. So technically, look at it. The curve, the x-axis, and then tell us about them want it from positive 2 to negative 2. It means is an area that is shaded right here. So we need to calculate the area that is shaded. The curve, the x-axis, x equal plus 2, x equal minus 2. What it means is that it is the area that is shaded green. The area under the curve is what it is that they want. Let me press pause and come back to one of my original stories. You have a plot of land. The shape of the land is this way. The shape of the land is this way. All right? You want to see how far you can go down for a swimming pool, for argument's sake. And you can, and this is the area under the curve that you're calculating in order to get that swimming pool. And this little piece out here says going to be a kid's pool. So you have a section on your property where you can put a pool. You can put a pool, You can put an adult pool right here, so, or you can put a jacuzzi here, so, or you can put a little kid's pool right there. So you want to find the area under the curve. You want to know what area you are dealing with in order to get the stuff, right? You're trying to find what area you're dealing with in order to get the stuff, right? So you're looking at the area under the curve, the area under the curve, right? The area under the curve. That's what it is that you're looking at. Now, I want you for me, because the topic finished already, I just explained it to you. What I want you to do for me is to integrate this function, this definite integral. I want you to integrate this definite integral. And that I want you to integrate this definite integral. And your upper limit is going to be 2, because remember your upper limit is a positive value, the bigger value, and the lower limit is a smaller value. So let us look at it. The bigger value here is going to be positive 2, and the smaller value is going to be negative 2. I know you know how to do this already because Sir did a whole lot of questions with you on this. I want you to integrate this function for me, the same one here, with the upper limit as 2 and the lower limit as negative 2. I give you 5 minutes to do that for me now, please, and thanks. Don't drop asleep on me, I'm expecting to be working. Hello?
Yes, sir.
You got the answer?
Yes, sir.
What answer you got?
I got -8.
Anybody else got -8?
Sir, me no know what me do.
Excuse me, Sash?
I don't know what I did, sir.
Excuse me, Sash? Anybody else
Sir,
got -8?
the low and the upper limit was +2 and -2, right?
Yes, let's done. -8 is a correct answer, but I want the rest of you to listen to me. I've done this topic. Charlie, let me ask you a question, dearest.
Yes, sir.
Is this anything different from what I taught you before?
No, sir.
Good. The only thing now is that pictorially, you weren't seeing what it is that I was talking about. True or false?
True, sir.
Right, but now you're seeing what it looks like pictorially. I spoke about it. I spoke about it when I was talking to you about the definite integral. Going on an avenue, you have a definite starting point and end point. But no, pictorially, you're seeing the graph. The graph is the only other thing that I need to show you, because I mean, you know how to do the question already. So let me ask the question again. Did anybody else got -8? If you didn't, I'm going to give you some time to work it, because I'm not working that one in class tonight. I'm not working that one in class tonight. I want to show you something else with the question. You know, matter of fact, let me give you 3 more minutes to sort yourself out, and then I'll come back to you. Incidentally, Yannick, I hate when you're in this mode here. I don't deal with that mode very, very kindly at all. You come to class and sit and don't even talk to me. Tariqam, you all right? Davia? Andrew, good?
Get in there, sir.
Nice. Avi, or you stay?
Get in there, sir.
Good, 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 good. Newbie, you good?
Yeah, man.
Yeah, cool, easy. Me not go ask, so you got to me say you want a flask of rum. Krishna, or you stay?
Working on it, sir.
Good. Nesta Bo. Long time you not talk to me now. Or you stay, Nesta?
Get it along, sir.
Very nice. Shanali, or you stay? Sean, how are you? Okay. Faint, but I heard you. Good. Zidane, you all right? I guess not. Always stay. Anybody else got the -8? Oh, this is not good. This is not good at all. May I have my class, please? It's not good at all. Where are my students?
So students, them tired.
Yeah, but just do the something so can't up and leave now. I did say to you that my plan tonight was to leave, let you guys early. But the longest stick to the question is the longer I'm gonna keep it because we have to finish this part of the question. I did say to you that the topic not going to take me more than 10 minutes because we've already know how to do it. So the longer the take is the longer we're going to be here.
All right, and tell sir something done now.
This is the last experience I'm gonna have with you guys for the semester, for this leg of the semester. And this impression is gonna leave with me until
Sir, you're just tired. Next year you
know,
come fresh.
No, but I too I'm tired, you know.
Yeah, me know.
Yeah, but I'm just saying, just because I did say to you that my plan when Charlene asked for the stuff, I said not a problem. My plan was to let you guys out from early tonight. Just to the little one simply so we can leave now.
Yeah, the excess, sir, yeah, guilt trip way.
We're getting accept. Me not talk to her now. Sir, I guilt trip. Go away. No, but it's true though. This is the last impression I'm having with you guys. So I'm gonna sit down and think about this impression for the whole Christmas.
Sorry, so if you did bring some rum coming at a party.
Listen to me. Mister, I forgot to talk to you what I'm going to drink after this. Can't talk to about the thing.
Top shelf.
Hey. Couldn't even spell it. Not quite. First and last impression, and then middle impression last too. The way them say, see me and come with me is two different something. First impression might be nice, you know. And then they say, yeah, man, I'm moving. And I said, Jesus, Father, what me do? Anybody else finished? Oh, Jesus. Last impression of come it me very well with the last. Maybe this is a taste of what is to come, and I don't like that taste, so I may just run. Mr. Lambert, can you unmute for me, please? See, Zidane can't sleep. It's the second time I call. And you answer me. Sean Anderson, can you unmute, please? You see where the energy there? You see where the energy there? More want to not come with the same energy to get me negative E for the answer. Sasha, oh, you stay? Rockstone.
That's a guy left you.
This is not good. This is definitely not good. I should ask for the cameras to go on now. Nestor, are you with me still?
Sir, don't play them serious shit.
Sir, I'm always with you, sir.
Okay. Woo. Did you get a -8?
Not quite as yet, sir.
Okay. Lexon, how you stay? I don't know. I think I bored a class tonight. Krishna, how you stay? Oh,
What was the answer, sir? Eight?
-8. Negative.
-8. Oh, I didn't get that.
Davio? Germany got an answer?
No, sir.
Are you still working at it or just put it down and waiting for me? Which one?
No, I'm open.
I kind of believe you, know. Trust me, so not way. Avi, you tell me see I work on it long time.
Yes, sir, I got -8.
Oh, Jesus, thank you. You know, when you're swimming and you're trying to lift up a little ear, I feel like you want to take off. Ah, that is very nice. I'm happy about that. Very good. Who else? Andrew, how you stay? Andrew, you can't disappoint me, no, Andrew.
What was that, sir?
What is up for the answer?
I didn't get -8.
Okay. I think I know what I'm going to do. I think I know what I'm going to do. I'm going to go back to the class. I'm going to do the thing and take vexation and go on my bed. Vexation and go on my bed.
Why is this, sir? I never hear.
Me I go take vexation and go on my bed. Okay. Oh, no, now work with me tonight. Oh, no, now work with me tonight. I'm assuming I'm going to know. But guess what? I'm not sending them notes tonight here. I'm going to sit down and do the work on our own. That's going to be a punishment.
Sir.
Sir.
Yes, sir.
Sir.
I don't hear no story from you, miss.
No, I'm not getting a story. I'm just say as long as you upload this.
The video? Yeah, the recording. You can still upload that, sir?
This class, I don't know.
I don't know. I don't know what is wrong with you, Yan. Anytime anybody trouble you in the day, you come out and take it out on me, and that's unfair.
No, sir, you notice I'm always late for Thursday class.
No, that me talk about, but you normally talk in my class. Are you in malice with me?
Sir, but me come in late, me I try grasp what go on. Me not go.
There's nothing for you to grasp. We have already done this piece. That's the point. We have done this piece. So guess what? Come. So we have Sasha, put on your
Your
glasses
fancy,
and
your fancy R and E confuse me.
okay, don't worry about it. The fancy E and R. So this is us reading X is a member of the set of real numbers. That's all it is saying.
Oh,
X is a
Sir,
set of all real. Yes, yes, Sasha. All right.
I have a confession to make.
What is it? You drop asleep.
No, sir,
Mm-mm.
I'm not following.
All right, come, let's go.
Sir, from last class, me not follow, sir.
Cockroach, and I know you tell me. Jesus.
Sir, but they don't plan for binge watch your recordings over.
Same.
Yes, sir.
I think that's what everybody going to do. Binge watch everything.
No, I'm not going to do that.
Just play along, Charlene. Just play along.
Charlene,
No, I can watch it. Me have Canvas Edica staff work on.
Charlene.
Charlene, you're good. But
Yeah,
for
you
me,
good.
I gotta watch the recording
Same.
last class so I can keep up with today's class, sir.
All the recordings are uploaded.
The back row attack, yes.
The only one that is out will be out is tonight, and I don't know if we can get anything much out of it because it is pitchy patchy. But anyway, let's go. Let us see if we can get a good piece in this one. Let's go. So this is a function x cubed minus 3x squared minus 3x minus 2, and I'm integrating the function. Now I don't know if you're not following from last week because this one is something that we did long time ago. We're adding 1 to the power, but this is not this piece is not, we call it stationary function, you know, stationary point. This piece is integration. So you're adding 1 to the power divided by the new power. See here, x cubed, you're adding 1 to the power divided by the new power. Adding 1 to the power, 3x to the square over 2 divided by the new power. Adding 1 to the power, so it becomes negative 2x. And you're integrating it between the limits negative 2 and positive 2. Anywhere in the function you see x, you're substituting all of 2. Anywhere in the function you see x, you're substituting all of negative 2. So this one is not stationary point, you know. This one is something that you have done from before, long time, and I don't understand this. So having integrated the function, I am then going to be applying my upper limit and my lower limit. I'm substituting my upper limit into the first half of the function. I'm going to subtract it from the substitution of the lower limit into the other function, into the same function, the integrated function. Then 2 to the 4th is going to be equals to 16. So that's going to be 16 over 4 minus 2 squares is 4, and 4 times 3 is 12. That's 12 over 2. And negative 2 times negative 2 is negative 4. Negative 2 to the 4th is going to also be 16 over 4. And negative 2 squares is going to be 4. And 4 times 3 is 12. So that is going to be 12 over 2. And negative 2 times negative 2 is going to be equals to positive 4. So again, I'm substituting my upper limit. This piece is representing my upper limit. This piece here is representing my lower limit. 2 to the 4th is 16 over 4. 2 to the 2nd power is 4 times 3 is 12 over 2. And negative 2 times 2 is negative 4. Negative 2 to the 4th power is 16 over 4. And negative 2 squares is 4 times 3 is 12 over 2. And negative 2 times negative 2 is positive 4. 16 over 4 is 4. 12 over 2 is 6. And that 4 is that 4. So I'm going to have 4 minus 6 minus 4. And again, 16 over 4 is going to be 4. And 12 over 2 is going to be 6. And then I'm going to have positive 4. All right. I'm sorry. And then 6 minus 4 is going to be negative 6. And 4 plus 4 is 8. And 8 minus 6 is going to be 2. And 2 times negative 1 is negative 2. So the answer is negative 8. Was that difficult? Sasha, talk to me. Was that difficult?
Nada, sir.
Okay. And was this what we did last week? Say
Was
no.
it?
No. This is integration, you know. This is
No, sir.
integration.
You did something different last class.
Which is the point I'm making. So I don't know why una play Stucky. I don't know why una play Stucky
I know
because
to do this, sir.
me know for do this. Me not ask you. Me not ask nobody. Me know for do it. That much I can tell you. I know you guys know how to do it. So we get -8. All right. So let us see if we can just finish off this. Because when you're tired and makes sense, me get caught up into my feelings for tonight. So let us see if we can finish off this one. So what I did for you while I'm waiting for you, while I was waiting for you with bated breath, is to show you that so let us go back to the let us go back to some people call out, no, they not even say, make them even answer, sir. No, it's not good. Look how one night you not gonna call me and me not gonna answer them. I'm not gonna feel away about it. I am hold on.
What's the name?
Say it again.
What's the name of what you just did? What's that topic?
Integration.
Okay.
All right, so let me just bring across a point. Okay, so that's what I was looking for. I was looking for the graph. So so we got -8. So -8 units squared. All right. Now, what does that mean? Let me just help you to interpret that, what that -8 unit squares mean. It means that I could dig a pool. If my unit is in meters, I could dig a pool 8 meters, as much as 8 meters deep. The area of what it is that I'm going to be doing is 8 meters. So the area under here will be 8 meters in total. All right. So that's what it is. Now, the negative sign is suggesting that I'm digging something below the surface of the earth. See there, the x-axis, right? So this is going to be, you notice that anything under here, under this line, the x-axis will be negative. So it is suggesting that I'm digging beneath the surface of the earth. So, I'm digging something, the area that I'm digging is going to be in total 8 meters. It's going to be 8 meters, 8 meters. Well, if my unit is meters, it's going to be 8 meters. So if it's a pool, and I want to go and tile the pool, like I went to this nice hotel, and trust me, normally when you go into a pool, the pool is painted and just the top half of the pool is tiled. But this very sexy pool was tiled right across in a very nice blue tile, and it gives a facade. When they turn on the light, the whole area at night is it is just a lovely blue looking, it is just breathtaking. All right. Now, if I wanted to tile this pool and I go to creative tiles, and they say, sir, how may I help you? I said, I am tiling a pool. What is the measurement of the thing? I know it's 8 meters squared. And so, okay, fine. And then just look at them calculate and them calculate 8 meters squared. I said, okay, what size tile you need, sir? I said, well, I need pool tiles. I'm going to need a very small ones. He said, okay, fine. And he know what 8 meters is. He knows that he may have 1 by 1 tiles. So he can say 1 by 1 and da 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 da. And calculate say, okay, so you need 100 boxes, right? And if you need 100 boxes, you're going to need 18 boxes of grout. And you're going to need this and you're going to need that. I said, okay, fine. Build me up so I can go and start, right? So this is what it is. This is what it means. So I'm only now interpreting what all of this is. You may wonder how this becomes a part of what it is that you're studying. It surely does become a part of it, because you may be doing something, you know, in your area of computer management, or you may do some GIS or some art view or some digitizing of something, and they say to you, you know, you may go into an architectural company to work, and they may say to you that, you know, we need to build a water tank. And I told you the story I read about water tank that is being built in an apartment near me. They need to know how far though them can go to build the water tank. So they need to know what it is. So when them go to the store now, they say, here the plan, I'm building a water tank, but it is going to be submerged, and cars are going to be parked on top of it. And say, okay, fine. You can't use a 3/8 steel. You can't use the 1/2 inch steel. You may need to use the 2-inch steel so that you know that you get the strength so that it don't collapse. So you have to go and it's 8 meters squared. So then we tell the boy to do your store up and to do this and to do that. You will need that, and you know them tell you how much steel you will need just to make sure that that place is firm enough so that when the cars sit on top of that well, that at no point in time will it cave in, right? So these are calculations that we need to have, and these are things that you need to know, because who to tell? Some of you may very well go into the banking system to work, and you may find yourself into an area of the bank where they're approving mortgages, and yours is going to be the task to go and run some numbers and do some stuff and say, no, I don't think this is going to be good, XYZ, so forth and so on. All right. So let me just give you a final thing and then we'll cut off. Since you don't want to talk to me tonight and I'm not going to get up into my feelings, let me just show you a quick thing. If you look at it, you could say that you have two pools. You have a pool here at -1 all the way down to +2, because this is the adult pool where, you know, I won't say adult things take place, but you know, just adult pool. You don't have to be able to touch the bottom of the pool. But this one is a kid's pool, right? You know, it's very shallow, etc., etc. If I want, I can find the area under the curve for the adult pool, for argument's sake, and then I can go ahead and find the area under the curve for the kids pool. And for sure, when I add both areas, I supposed to get my total area as -8 unit squares, right? So let us see if that works. So remember, you know, this is going to be -1 to +2. This is -2 to -1. So my alternative calculation, I did the alternative calculation before because I was hoping that you guys would have remembered how to do your integration. Oh, I was wrong. All right. So alternatively, I'm finding the limit between -1 and 2, which is my adult pool, the adult side of the pool. All right. So I'm integrating. You'll recognize that the function is exactly the same as the one we got before because the function is not changing. So when I integrate it, I'm getting the same thing. The only difference now is that my upper limit is still going to be 2. My upper limit is still going to be 2, but my lower limit in this case now is going to be -1 and not -2. All right. So anywhere in the integrated function I see x, I'm going to substitute my upper limit, and then I'm going to minus that from the same integrated function. Anywhere in it I see x, I'm going to put -1. So it becomes now, so you'd have this in the original question that I did. Osh, never mind. We soon finish. I soon finish up. By 9:45 I finish. And then you can just take the time and then you can come back at this when it's fresh. And then this, and anywhere in the function I see x, I'm going to put -1. So it's going to be -1 to the 4th over 4 minus 3 times -1 squares over 2 minus 2 times -1. So again, we're evaluating 2 to the 4th is 16 over 4. 2 squares is 4. 4 times 3 is 12. And that is over 2. And -2 times 2 is -4. -1 to the 4th is +1. So that becomes 1/4. And -1 squares is going to be 1. And 1 times 3 is 3. -2 times -1 is going to be +2. And of course, 16/4 is the same thing as 4. 12/2 is the same thing as 6. And that 4 is there. 4 minus 6 is -2, -2 minus 4 is -6. And trust me, when you evaluate 1/4 minus 3/2 plus 2, you're going to get -3/4. And that is going to give you -27/4. So the area of the adult pool, is going to be -24 units squared. All right. And then for the kids pool, remember the kids pool, is going to be the upper limit is going to be -1 and the lower limit is going to be -2. So it's a continuation of the question. Watch me. Remember we did 2 to -2. Watch this. This is going to be 2 to -1 and then now -1 to -2. So I'm doing it in 2 tranches. Again, it's the same integrated function. All I'm going to be doing now is to make my substitution. The answer I would have gotten here, -3/4, will be the same 3/4 on this side. 1/4 minus 3/2 plus 2. 1/4 minus 3/2 plus 2 because it's a continuation. And then when I do the substitution of the -2, I'm going to get -2 to the 4th. It's going to be 16/4. -2 squares is going to be 4 and 4 times 3 is 12. 12 over 2. And -2 times -2 is +4. 16/4 is going to be 4. 12/2 is going to be 6. And to put the 4 there. 4 minus 6 is -2. -2 plus 4 is going to be a +2. And that +2 times this negative sign gives me a -2. So the area of the kids pool is going to be -5/4 unit squares. And trust me, when you add both of them, areas, -27/4 minus 5/4. The denominators are the same, so I add my numerator. 27 and 5 is 32. I'm going to have -32/4 and 4/8 32 equals -8. So what's the point? The point is that I can break up my integration. It is possible because in this particular case I saw where the two pools actually separate in reality. but it's just that one joins the other. They have the same connecting point, but two different pools in itself. So I could find the area of one, then find the area of the other. And when I add both areas, I should get the same area as if I were to do one calculation. And we're able to do those one calculation because the pools join each other. The pools join each other, for example. So, without any further ado, since you don't want to talk to me tonight, the very last day of class for this leg of the semester, I'll bid you good night and ask that you say your prayers and confess your sins of not speaking to your teacher tonight. Have a good one.
Good night, sir.
I will not sleep.
Good night, sir. Bye.
Thanks, sir.
Good night.